Okay, so yeah, we'll be starting joins from today. That were different types of joins, how to use the joins. Okay, what is mean by actually joins? Okay, so those all things we will cover in upcoming 2-3 days. Okay, there will be use cases. So all those things we'll be covering there. Okay, so join is an important concept in SQL Server. Okay, you might have been seeing that in during maybe exercise as well, but if not, like we'll be covering that here. Okay, so SQL Server joins, as we have mentioned in relational database, the data will be stored across multiple related tables. Okay, from the day one we are talking about this. Even when we saw that first like few lectures in the PPT, there were also some examples we were having. Okay, like this relational model example where we have the employee table and we are having two more table called designation and the place. Okay, so we are having the relation between those three tables with each other, right? So employee information, we don't have the directly designation. Instead of that, we are having the key which is pointing to the designation table, and same for the place table as well. We don't have the directly place information. Instead of that, what we have is we have the key pointing to the place information. Okay, so like this, the data will be stored across multiple tables in the real time as well in the actual projects as well. Okay, we have this AdventureWorks database as well. Okay, in this as well, we have the multiple related table. Instead of storing all the information into a single table, we have this multiple tables. For example, this employee or the human resource schema, if you see, we have the employee table is a main table, and then we have some other tables as well where we are storing the different information. Okay, so we have the department table where we are storing the department information of the employee. Then we have the department history table if there is multiple changes into the departments for that particular employee. So that change history also we are maintaining into this department history table. Then payment history of that particular employee we are storing into this payment history table. Then job candidate shift details, like this, like work details, we are having this all tables related to the employee information. Okay, so like this, the data will be stored across multiple tables, because if you store the data into a single table, like entire set of data, there will be a multiple repeated values, multiple repeated columns can be also there. Okay, and which will lead you to wastage of space because of the repeating information. It will take some more space, as well as it will be we will be having a challenges during updates or deletes, as well as we need to deal with the multiple records. Instead of doing the updates or delete for a single record, we will end up with like processing multiple rows without any need. Okay, so for all this data will be stored across multiple tables so that we will have the accurate and integrated data. Okay, it will be easier to maintain the data without any data duplication. Okay, and for that only we will be having a data stored across multiple tables. Okay, and those are the logical tables. That means logically we will be distributing the data across multiple tables. Okay, now when we have the data stored across multiple tables, right, what we need to do, let's say I wanted to know the employee name. Okay, then employee department names, right? We need to get the we need to write the query in a different uh, on a different tables, right? So in this employee table, what I will get is okay. So to get the employee information, I need to write the query on the this employee table. Okay, but if you see in this employee table, we don't have the name of the employee. It is just having the information about like national ID number, some key identity we are having, then organization node, organization level, job title, those things we are having. marital status, gender, and all. If you have to take the name of this employee, what we need to do is we need to go to the person table, because in this table only we have the names. Okay, so these are the two tables we are having. If you wanted to get the name of that employee, what we need to do is we need to query two times, two different tables. Okay, like business entity ID 1, and this is the business entity ID 1. So the name of that employee is this Kane something Sanchez, right? So we are having this name for this business entity ID 1, which is employee ID 1. For second as well, we will see some Teleduffy as a name. Okay, so two different tables we are having. Now, same thing, if you want to see the department of this business entity ID 1 and 2, what you need to do, you need to write a query against the department table. Okay, so in this table, we have these two departments alone. Okay, but we have the department ID. So let's check if you have the department ID into this employee table. Okay, we don't see the department ID into the employee table. So again, one more table should be there, which will be used for joining employee and the department both. Okay, so for business entity ID, this is the department ID we are having. Okay, so 16 and 1. So we don't have the 16 department ID into the department table. Oh, it should be because we are using top two. So department ID 16 is executive. So I can say this business entity ID 1, which is nothing but the person called Kane, is working as an executive. So if you see, to get the accurate information, or we can say to get like complete a set of data, a meaningful set of data, we need to query data from multiple tables, right? And to write the query for the multiple tables, currently we are using the separate queries. But if, let's say, I want these details like employee ID, okay, then name of the employee, then let's say we want the department name as well, department name. So I want this information into a single select query. So in such cases, we can use the joins to join those all tables together and get the single result set. Okay, so like for this example, if I want to see the business entity ID 1, for this business entity ID 1, I wanted to see all these details like name of the employee, department name of the employee. Okay, so this all we need. So I can simply use business entity ID is equal to 1. Here also I can use the same, where business entity ID is equal to 1. Here we don't have the business entity ID in the department table. So in history table, we can use where business entity ID is equal to 1. Okay. And now we are not sure what is the department ID, because we don't have the department ID directly into the employee table. So first we need to query this all. So this is the business entity ID. This is the name of that person, of that employee, and this is the department ID of that employee. So now you can search for the department using the department ID against that person, where department ID is equal to 16. Okay, so this is the complete details about that employee. Okay, the person detail like name of the person, other information like title, row ID, or demographics. So this all information we are having about that person. Then the department detail as well we are having. Okay, and yeah, department ID. So this information I want into a single row. Now here we are having four different result set. I don't want that. I want these details into a single result set. That I cannot do using multiple queries, and that is where the SQL join comes in. Okay, so to get the complete meaningful set of data, okay, we need to join those tables together using the different types of join. Okay, so SQL Server supports many kinds of join, including inner join, left join, right join, full outer join, self join, and cross join. So these are the different types of joins we are having in SQL Server. What we have here, inner join. Okay, then we are having outer join. In outer join, there are two types of joins. We are having three types of join: left outer, right outer, or we can simply say right join as well. Same for the left as well. Left outer, or we can simply say left join. Then third one is a full outer, or we can say full outer join. Okay. So either left outer join or left join, right outer join or right join, full outer join or full join we can say. Then another type is we are having is self join, and we have the cross join. Okay, so these are the different types of joins we are having in SQL Server. Inner join, left join, right join, full outer join, self join, and cross join. Okay, each join type specifies how the SQL Server uses data from one table to select the rows into the another table. Okay, so there is a meaning of each of this type, and this will define what kind of data you will get from both of the tables for these different types of joins here. Okay, so if you have to define, like the interview question is, what is SQL Server join and what are the different types of joins we are having? What you will say? So joins in SQL Server is used to retrieve the data from multiple tables. This will be your definition. Joins are used to retrieve the data from multiple tables in SQL Server. Okay, SQL Server joins is performed whenever two or more tables are joined uh, in a SQL statements. Okay, so we can simply say we can join two or multiple tables. Okay, but minimum should be two table. Minimum two tables should be there to use the join condition. Okay, there are four different types of joins we are having. Inner join. Okay, sometimes simply called as a join as well. Okay, then SQL Server left outer join, sometimes called left join, right outer join, which is also called as a right join, full outer join, also called as a full join. Okay, then apart from that, we are having two more called cross join and self join as well. Okay, so these are the major four types, and within outer join, there are three subtypes we are having. Okay, so types of join: inner join, self join, outer join, and cross join. In outer join, there are three: left, right, and full. Okay, we'll see significance of all of them one by one. One more important thing, to use the join in SQL Server, there should be a common column. Common column in the sense not by the name. Okay, now here with this example, if you see this column in the designation table, pk integer id is the not I could say this name of the column is not same as this column name fk integer designation, right? So column name can be anything, okay, but it should have the same kind of data, in the sense. So this is the designation id, so same designation id should be stored in this column. Okay, if this is a place id, so same place id should be stored into this column. So to use the join condition, there should be at least one common column exists between those two or more tables. Okay, then only we can use the join. Okay, with this example, our adventure works example, let's say I wanted to join the business entity, this employee table with person table. What is the common column we are having? you're
Business
having
Yes.
entity.
business entity
Yes,
ID.
sir.
If you wanted to join person table with department table, person table with department table, do we have anything common in between those two tables?
No.
No. So we cannot directly join those two tables. So to join the department table with the person table, what you need to do is you need to first join this person table with department history, because where we have the common column called business entity ID, and then you can join the department ID with the department ID into the department table. So from one table to another table, this is how we go. Okay, to get the meaningful insights, meaningful set of data.
Common data means common data type, or what kind of data we should have?
No, it is not a common data type. Okay, so if one column is storing the information about the department ID, so the another table should also have the department IDs stored. Okay, it may be in the column called dep ID, it may be called just ID, it may be called like department IDs or something like that. But if one column is storing the department ID in one table, in the another table also it should store the department IDs. Okay, that is what common data means. It is not a common data type. Okay, usually it will have a common data type only. Okay, but it is possible to join the columns with a different data types as well. Okay, so it is not, when we say common data, it is not like a common data type. Okay, the type of data should be same between those two tables. Okay, so somewhere we are storing national ID number, then if you have to join based on that in another table as well, it should have the national ID number only. Okay,
Okay. It should be the similar number, right?
right. Similar
What
values.
about the column? Column name can be different, right?
Column name can be anything. Okay,
So, sir,
So
how do we know that if column name will be different, then how do we know that the value is same over there? So
right. So
we have to see the
this is
foreign key.
right. So this is just as an example. Okay, we can have a different column name, but usually we will have a similar kind of column name. Okay, not exactly same, but with this example, if you go here, this is a saying like it is a FK designation. Okay, so this is a designation. So we can see like this is the designation IDs. Okay, and we can identify like this is the designation IDs, and we can go to the designation table, look for the value against that ID. Okay, so in real time also we will be having the columns like this only, not entirely different column name we may have. Sometimes we may have such kind of data as well, but when you are working and you know all the tables, you will be able to get that information.
Okay, sir. Thank you.
Okay.
Mhm.
Okay. And one more thing, it is not required to have the primary key and foreign key relationship to join those tables. Okay. It is not mandatory to have those columns as in a relationship. Okay. Relationship is important only for keeping your data accurate and like you to have the data as an integrated data. Okay, but it is not, this is not a mandatory to have the primary key foreign key relationship for your table.
to join,
Okay, to
right?
use the join.
Yeah. So what is the main use of foreign key and primary key? Where we
Right, so
mainly.
use of primary key and foreign key relationship is to keep your data accurate. Okay, let's say now I'm keeping this employee table. Okay, and I'm storing the designation here. I'm adding some new employee and I'm adding the designation ID as a 10. Okay, I'm adding some new 10 employees and I'm adding the designation ID as a 8. So if I wanted to see what exactly the designation of those employees, newly added employees where the designation ID is 8 or 10,
Mhm.
how I can identify what is the designation, whether those are supervisor, whether those are engineer, whether those are clerk or executive. How do I know? I know the ID, but I wanted to know the designation definition. and the ID is like 8 or 10. That is not correct, right? Because we don't those designation IDs are not exist into our master table, our designation table,
Mhm.
right? So we will not be able to define those. So there is what the foreign key relationship will help. If you have the foreign key relationship, it will not allow you to insert the designations which do not exist into this table. It will not allow you to insert the places which are not exist into the place table. Okay, so the primary key values should exist. Then only we can insert this data into these columns, foreign key columns. That is the use. It will keep your data integrity. It will not miss to. It will check the data is exist or not, and then only it will allow to insert. Someone, let's say, deleting the employee records. Let's say we don't have the foreign key relationship, and someone has deleted the record from this designation table. He has deleted the record for the supervisor. The like integer ID is equal to 2. He has deleted the record here. Okay. Now what is the meaning of this record 1001? It is having the designation as a 2. Okay. So it is having the designation as a 2. He is a supervisor. But to know he is a supervisor, we should have the record here into this table. But it is deleted by mistake, right? But if you have the foreign key relationship, it will not allow you to delete this record as well, because there are some employees which are tied with this employee designation ID as a 2. Okay, so it will maintain the data integrity, it will maintain the accurate data. Okay, and it will not allow you to perform the action which will cause to destroy the links between the tables. Okay,
I have
you
a
got it?
question, sister. So, does foreign key constraint, like, do you put that first? Do you create this TBL design table first, or like when you're creating the main table, like employee table, you specify this is the foreign key?
No,
It's
first will be the primary key tables we need to create. First, we need to insert these data like designation and the place tables, and then insert the data, and then we will create the transactional table like employee table. Right, because if you have created these three tables, okay, for creation, you can first we need to create a primary key table, then only we can reference that primary key into the foreign key table here. Right,
yeah,
because to create
right.
a foreign key, we need to give the reference. And our definition says, what is the definition of foreign key constraint? We need to write a foreign key, give the key name, then use the references keyword, and then we have to give the reference for table name dot column name. So there, if we don't have the table exist, the primary key table, it will throw the error. So first, always primary key table should be there, then only we can create a foreign key constraint.
Okay.
Okay.
So this is something you have to like think about in your schema when you before you even make a table. Like, all right, these are the tables we're gonna have. Because for example, employee table is gonna need if you is gonna need you know like uh like the roles, like numbered roles. So um you just in the schema you prepare that before it all happens. It's gonna all connect at the end, right?
Right. Right. So before actually creating the table, normally, if you are assigned to any project, right, you will be having some, uh, you will be maintaining some of the data before actually creating the tables. You will have some uh, definitions like this. Okay, so this is the table we need to create. Okay, you will define the columns, table name, data type. Okay, before actually executing, before actually creating those tables, you will create those tables into such Excel format or some notepad. Somewhere you will create the tables first, define the columns, and then you will create the tables actually in the SQL Server. So we will get to know like which table should be created first. Okay, and then which tables should be created later on. Okay, which is a primary key table, which is a foreign key table that we can define first, and then we can create those.
And is this created before the flowcharts or after? This is probably created first, and then you know how like floats. I don't know if I'm using the term right, but I think it's called flowcharts, right? Where you connect, you have lines, and
This
you connect
is
different tables.
all right. So that we can call a flowchart, as well as flowchart will be like flow of the process,
Yeah,
uh, which table should be, or which process should be first run, which should be second, and so on, based on the decision and decision flow. Okay, so this is also can be called as a flow chart, or we can call this as a database diagrams as well.
database type.
Yes. Okay.
Yep.
Okay, so let's talk about the first table. Before that, I'll create some two tables and I will insert some data also there. Okay, I'm having some two tables with ready structure. Actually, I'm not having just two, I'm having more than two, three tables I'm having. So we'll be using these for our demo and practice. Okay, I'm having table called departments, and I'm having some 7 records to insert into this department table. Give this all to 31. Then I'm having employee table. Okay, this is already exist. So I will just give some another name here. Employee data or something. Okay, so in this employee table, we are having employee ID, name of the employee, designation, and department ID, manager ID, salary. Okay, so we are storing manager ID and salary in a separate fields there. Okay, so let me create this and execute this as well to insert some records, around 15 records. And one more table we are having called projects. So in this we are having project ID, project name, and we don't have the employee information like name of the employee tag to this project. We have the employee ID, which is referencing to the employees table, employee data table. Okay, so like this, I'm creating 3 different tables and inserting the data into these 3 different tables. This will be used for our demo on this join departments.
That employee ID should exactly be matched with employee data, right?
Right. Then when we can say it is a valid data. Employee data. Let's start from video dot projects. So these are the 3 tables we are having. In departments, we are having 7 departments. Okay, along with the department name, it is storing the location of the department as well. Okay, then we have the employee data, in which we have the employee ID, name of the employee, designation, department ID, manager ID, and salary. Okay, and third table we have, which is storing the project's information. So name of the project, okay, ID, project name, the employee ID working against that project, project cost, and start date. So such kind of information we are having here. Okay, so this we will be using. The first type of join is a inner join. Okay, so what is inner join? So the definition is, so SQL Server inner join returns all the rows from multiple tables where the join condition is met. Now, what is join condition, or what is mean by when it is join condition is met? Okay. In other terms, we can say SQL Server inner join will return all the matching rows from 2 or more tables. Okay. For example, okay, this is a table 1. Okay, and this is a table 2. So wherever there is a match, like we are having this intersection with, like, which is common between both the tables. So only this data will be retrieved when we use the inner join. Okay, so inner join will return the matching data from two or more tables. Okay, so we will not get this data because this data is not present in table 2. Okay, or like this table 2 data is not present into the table 1. Okay, it is this portion only which is having the common data between both of these tables, and that is what SQL inner join will retrieve. Okay, so SQL inner join will retrieve only the data which is a shared data between those two tables. Okay, so we will see with example how it will looks like. Okay, but this is a syntax for this inner join.
One second,
I
sir.
will,
What
yes,
about the non-matching data? Is that a null value populating or
we will
that
see that. Okay,
ignored?
yeah, we will see with example. So inner join will return the matching data from two or more tables, we can say. Okay, inner join is used to retrieve the matching data from two or more tables. Okay, and this is the syntax we are having. We can write select column list like column 1, column 2, column 3 from table 1. Then we use inner join to join the table 1 with table 2. So what I'm saying, join table 1. Okay, table 1 join with table 2, and this is on, which is nothing but the join condition. So based on which column you are going to join, that you need to specify here on table 1 dot column name, table 2 dot column name. Okay, so let's see with this information here. We are having these two tables. I'll just get top two records here. Okay, so we have common column between those two tables is department ID, right?
Yes.
If I wanted to join the employee table and department table, I can use the department ID as a column. Okay, and what I need is I need employee ID, employee name. Okay, I want department name and location. I want only these four columns. I don't need the department ID in the select list. I don't need the designation. I don't need the manager and salary. Okay, this information I don't need. So how I can write the query for this? Select, okay, from, I'll just say dvo.employee data. Then I can use join condition, because as we are using join, we can mention inner join or simple join as well, because definition we have seen here, it is also called as join as well. Okay, so we can specify inner join or join. Okay, both should be fine. Then dvo dot department, I need to join this table with departments table. Now on is the condition we are having, which is used for joining the two tables. On which column you are going to join, so that you need to specify. How you need to specify? Table 1 dot column name, table 2 dot column name. So employee data dot department ID is equal to departments table
Dot employee ID.
dot department ID. So we don't
Department
have
ID.
employee
Yeah.
ID. Yeah,
Yeah.
we don't have the employee ID here, right? So department ID is a common column. So this is a common column. Now you can write your select list, because it will give you the intelligence, like it will identify what columns you are going to see. Okay, if you are writing first select list, okay, you need to know the accurate column name. Okay, so this method you can use. First you write the from clause, even it is a single select statement as well. So first write select from table name, then the column name will be appearing there as you start to type. Okay, so name we are having employee name. Then we have what we need, department name. So department name and
Location.
location. Okay, so these are the four columns we need. If you execute this, you will get this common data. We are getting 114 records here. Okay, sorry, only 12 records we are getting here, right? Only 12 records. Now, how many records are there into the employee table? we are having 14 records, right? 14 records we are having. So there should be 14 employees with the department information as well, but still we are getting only 12 records. Why we are getting this? Because we are using inner join, and inner join will retrieve only the matching records. So there are two employees where we don't have the department ID. So this null is not present, or this department ID null is not present into the department table, which is the reason we are not getting the information of these two employees where we have the department ID as a null value 112, 111. So if you execute this, you are not getting these two employees 111 and 112. You getting this?
Sir, can we add one more table on this syntax?
Yeah, we can have as many tables. Okay. There should be a common column. We are going to see that example as well. But as of now, are you understanding this? Why we are not getting this employee ID 111 and 112?
Because
Because of the null.
they have different, null
Not
value,
matching.
not matching.
Correct.
Yeah.
Because they are having the non-matching value for the department's table. Right? Department ID.
Yeah,
If
they
you
don't
insert
have
the
the
null,
department.
what will happen? So
So,
if I insert one more record into this table
mhm.
with null as a ID, okay, it will not allow you to insert that because it is a primary key,
Mhm.
right?
Yes.
The department ID is a primary key, and if you try to insert the null value into this,
It won't
whether it
work.
will allow you, it will
No.
not work. Okay, so let me drop this table and drop the primary key just because we wanted to see what will happen if we have the null record into the department table as well. I'm dropping this table and recreating this table without primary key. So I can insert the null value.
If there is primary key, can't we add the data?
It is a primary key, so we cannot add the null value to the primary key column, right?
Oh, yeah. Null value.
Okay, so we have inserted this null value now into the departments table. Okay, so we have the null value and we have the null departments present into the employee table as well, right? So there are two employees who is having the null as a department ID. Okay,
Yeah.
and we will see whether we will get that employees 111 and 112. Still, we are not getting those employees. So inner join, when we use, okay, null will not be considered as a value and it will not return the data where null is equal to null. Okay, so nulls will be ignored
In inner join.
in inner join. Okay, so null values will be ignored in the inner join. So it will not match based on the null is equal to null. Okay, so even we are
Okay.
having the null values, it is not returning that record 111 and 112. Okay.
So
So
this,
what?
okay, go ahead.
No, Raji, you go ahead. It's fine.
Okay, yeah. For this inner join, it shows us the common values. I mean, it retrieved the common values. So uh, can we interchange that from DB employee data with department?
Right, we can do, it will return the same set of data. Okay.
Yeah, but
Whether you will write the first this table or first this table, it
because
doesn't matter.
it's gonna retrieve the common value. But in
Right,
case of
it is
left
gonna
and
retrieve the
right,
common
it will be
values.
different. Yeah. Okay. Okay.
It's both will give you the same result.
Mhm.
12 rows, 12 rows.
It doesn't matter the order, right? We can use
Right.
either
So
one.
it doesn't matter which table you are using in from clause, which table you are using in join clause. Okay. So because this is in a join, it will retrieve the common data between those two tables.
Mhm.
Sir, can you show that table like both from those? So for example, here the employee ID is like 101, 102, 103. Like for example, it is like if it is like 75 or 76 instead of like 101, 102, 103, it will not retrieve that also, right? Because it is different.
It will retrieve, right?
It will
Because we are
retrieve.
not joining based on the employee ID. We are joining based on the department ID.
So for example, in department ID, if it is like 2000, but
It will not retrieve,
okay, okay, got it. Okay,
right?
thanks.
It will not retrieve that data.
Whatever the common value we have, then only it will be retrieved, right?
Right.
Yeah.
Only for the common values. Okay. Now let's say, see, this syntax is like, looks like complex. This is now a simple table name we are having. What if your table name is like this,
That much of long.
a bigger table name? Okay. Like this. So we have to use the table name here as well, right? In on condition from this table, what column you are taking. So instead of that, we can use the alias name as well in the tables. Like we have seen the alias name for the columns, right? As we were mentioning, and some column name we are giving. So here also we can use the alias name. We can use as, or we can simply give the direct name as well. So this department table, I'm specifying this as a D. This I'm specifying as a E. Okay, so now this D and E we can utilize here so that our syntax will looks quite simple. Okay, D and E we can use here. Okay, even we can specify the table names here as well. So this employee ID is from the employee table. Employee name is also from the employee table. Department name is from department table. Location is also from the department table. Okay, so alias name we can use here in the joins, okay, to give the shorter name to the tables so that we don't have to repeat the table values like table names again and again, and it should not complicate our query. So now you see this is the query we are having and this is the query. So somewhat it will look like simple or simpler because we are not repeating these values here, right? Bigger values. Again, I'm saying this is a simple table name. What if your table name is like this longer, right? So you have to uh, write that full name here as well. Okay, and again, let's say you want the project information as well. Okay, so what are the employees we are associated with the project? Let's say you want the name of the project and start date of the project in your result set. So what you need to do? Again, you need to join the projects table, right? Projects table, and then write the on condition. Now what is the common column between an employee and project? We have the, let's say I'm giving this name as a P dot employee ID. We are having a common column as an employee ID to E dot employee ID. Okay, so we are finding out the projects where the employee IDs are, like employees are assigned to the project. Okay, so from the project, I need the project name and P dot start date. Okay, so these two columns I need from the project table. So here as well, we will get information only for the, now we are getting the information only for the 10 rows. Okay, it is now again removed 2 rows. Okay, earlier when we are joining with this table, employee and the department, we were getting 12 rows. But now when we add one more table called projects, now we are getting only 10 rows. Now why? Because there are some employees, okay, which are not assigned to any of the project, or there are some project we can say where we don't have the employee ID. So let's check on this. Okay, so there are some projects we are having. We don't have the employee ID for those projects.
If
Okay,
we use
so
three tables, then it's gonna use the combination of 3 columns.
right. So in all those tables, we should have the common values like that. Okay, so it will look for the entire things.
Yeah.
Okay, so yeah, so join, we can use the join condition to retrieve the data from multiple tables. We can use multiple tables here. Okay, either it can be 2 tables or 3 tables or 4 tables we can use in the joins. Okay, we can assign the we can assign the like alias name to the tables so that we can use this like simpler name in the join condition.
Yeah,
Okay,
simplify,
same.
yeah.
Right. So these names we can use in select list as well to identify which column exactly, because we know like there are multiple columns we are writing in the select clause. Okay, if it is a single table, we can know these all columns are coming from this table. But now we are using a multiple tables here, so we should know which column is coming from which table. So that to better identification, we have to write the select clause like this when we are using the joins, so that we can identify this table or this column is coming from which table.
Mhm.
Okay. Okay, so yeah, this is what the inner join is. We can specify inner join or a simple join keyword as well means it is a inner join. Okay, null will be ignored in the inner join. Even though you are having null records in both the tables, null will not match with the null. Okay, it will be totally ignored in the inner join.
Sure. What did you say about inner join and join? Is it it's the same thing?
Right, it is the same thing. Okay, whether you specify inner join or you just specify simple join keyword, both means the inner join only.
Okay. So do you think inner join is the most used join overall? Because it pretty
Right,
much connects all the.
correct. Okay, that is what here also I mentioned. It is the most common type of join. Okay, that is used in projects.
Uh,
Okay.
can you go back to the SQL Server? Just have a quick question. So in this, right, can you just put, let's say you want to display all the data. Can you put like select star from and
Right.
get all the,
Okay. So yeah, we can put it, but that is not recommended because we should know what exactly the column's name is. Okay. Currently we are having only 5 or 6 columns or 2 or 3 columns per table, but in actual tables you will be having around like 20, 30, hundreds of columns you will be having into a single table. Okay, so it is recommended to use the actual column name. Okay, whatever it is required, only that column should be selected. But if you write the star, what it will get is it will get all the columns from all these 3 tables. Okay, so we are having first 3 columns from the department table because our first table is department, right? Then we
yes.
have the next 4 columns. Okay. Next 5 columns or 6 columns from the employee table, and then remaining columns from the projects table like this. Okay. So we'll get all the columns from the entire set of table, all the 3 tables. Okay. And still we get only 10 rows. Okay. Which means we are getting only common data. If you want only the data from the employee table, so what you can write e dot star as well fine, because e is for the employee table and I want all the records or all the columns from the employee table alone. So I can write e dot star. I will get only the columns from the employee table. If you want only from the projects, you can specify project dot star and you will get only the data from the project table. Okay, so we can write star as well there. Okay, but it is not recommended. We will end up with getting the unnecessary all the columns. So it is recommended to use only those columns in the select list which are really required in your result set. Okay.
You know how like this, right, this query right here, it specifies the one you were highlighting, e dot with the aliases for all the, yeah. So this one, for example, you have uh, aliases for everything, right? Can you go up the query before this? Where you have all the tables, right? Right here, the one down below, e dot employee ID, d dot department name, this one, yes. This one mentions all the table, but if you go up to the first one thing, it only mentions like when you're
Actual
joining, are
table.
you joining like I guess my question is with this particular query right here, are you joining departments table to employee data so that you're like getting the data? Because you know how you write a query saying that select from just one database, but you're connecting it later.
Yes,
No, it is not
define a
from
tree
the
data.
one.
It's
This
define
is
a
from
tree table, and there is a alias name, and from which table, which column do you want that is representing in a select from section
list.
on one. So it is easy to which column you are retrieving from these all three tables. So giving alias name, column name with the alias name is defined that it will retrieve the particular table, particular column only.
So here as well, we are not getting
I
the
guess
data
what I'm
only from one table. Okay, we are not getting only from the one table. So we are getting the data from second table as well. So department name and location is coming from the second table, not only from the first table. And that's why we are joining these two things. If I want the data only from one table, I don't need to write the join condition, right?
yeah. I'm overthinking. I get it. I was just like with the aliases, I guess I'm not thinking about the inner join part. I understand the concept, but I was just overthinking about, I guess the aliases is just I understand it now. It's fine. Thank you.
And
Yes,
sir,
LIC
one
is
more
only for the
thing.
understanding.
We
Yes,
can interchange the table, right? Like from employee data, like instead of there, we can put departments, and in the inner join, we can put like employee data. We can
right.
interchange.
So the interchanging the tables will absolutely works, okay, with the inner join, because anyway it will return the only matching records.
Matching.
So no
Okay.
matter whether you write the department first or the employee data first, it will return the matching data only from both the
Okay.
tables.
Okay. Thank you.
So for the alias, we use employee ID as E, department name, department table for the D. If we have a common type of table like product and product category, so what kind of alias we use? PP, or we can use any kind of.
Any name. So Ali's name is nothing like we should use always first letter or something like that. No, you can have
Okay,
any name. Okay, you don't want the E as a name, you can write EMP, shorter than this.
okay,
Okay,
two,
but the
two
purpose
letter.
of this analysis, it should be like easy to read. Okay, your syntax should be making it like simpler syntax it should make. Okay,
Mm-hmm.
so
If
that only
easy,
we are using this alias
if
name.
if we have common type of name, type of data, then we can use yeah, as
Right.
per our we see. Okay, got it.
Okay.
So
You can
like if we
use
have
any.
like you are saying like if we have like project order, we can put PO. If we have like project category, we can put PC, something like that. So
Yeah, yeah, that's what I am
Right.
saying.
Right. You can put. Okay, so now with this inner join, what we got is we got all the employees who have been assigned to a specific department and who has been assigned to us, like who has been assigned to a specific project. We did not get any employees who does not have either project or who does not have either department, right? We did not got the information about these two employees, or we did not got the information about these two projects as well, because we are not having this like two projects. We don't have this project with any of the employees. So when we run this, we are getting only those employees who are having a valid department ID, and who are we are getting only those projects who are having the employees assigned to that project. Okay, so only matching record we are getting. Now let's say you want all the employees. Okay, you want all the employees, irrespective whether you are having any department assigned or not. So how to retrieve that? Because using inner join, it is not possible to get those employees who are not having any department assigned to them.
Full join.
No. So there is another type of join we are having, which is a left join. Okay. So the second type of join is a left join. So left
Uh,
join, or we can say left outer join. Okay. So this join returns all the rows from the left table in combination with matching rows on the right table. So it will get matching records as well as all the records from the left table. Okay, that is how it is. That means if you go with this diagram here, what left join will give you? It will give you the matching values as well as this remaining portion from the left table as well. Like all the records from the left table plus matching records from both the tables, it will return. It will not return the non-matching record from the second table. Okay, we'll
Once
go with
again,
this. So yeah.
yeah, the last query inner join. How to improve the performance of query? Like, is there any way we can optimize the performance of that query?
See, performance optimization is a separate topic. We will talk about it. Okay, but when we are having inner join, okay, that is or any kind of join, the one way to optimize is to use the column list instead of using star. Okay, that is why I was mentioned it is recommended to use the column name. Because star, when we are using hashtag in the select list, it will end up with unnecessary reads, okay, which are not required columns. It will reading all those, it will utilize some extra memory and all. So it will end up with like issue with the performance. So the first thing is you should use only those columns which are actually required in your result set. So it is always recommended to use the select column list instead of select star. Okay, that is one thing.
Mm,
Second thing is when you are joining the tables, okay, you should have the from clause we are having, right? So from clause table should be the table which is having a higher data, or we can say maximum data or max row count.
okay,
So
the first table should be
the recommend
having maximum counts of row. Am I right?
right, right. So employee table should be used in the from clause and then in a join like the department table into the join. Okay, this is for performance optimization. Okay, and that is a separate topic. We'll be talking later on. But as you have asked, so I'm just telling you. Okay,
Okay,
but no matter whether you are writing this or this first, it will not impact on the result. Result will be the same. Only the thing is
execution.
performance. Yes, execution time. Okay. Yeah. Then second type of join we were talking, left join. Okay, that is one of the subtype into the outer join. Okay, and left outer join, also known as a left join. This join returns all the rows from the left table, okay, combined with the matching rows of the right table. So this is the definition we are having. Left join, this returns all the rows from the left table combined with matching rows of the right table. If there is no match, the value against that will be returned as a null values. Okay, so if there is no match we are having, so we will be getting the null as a values against that column rows. Okay, so let's see with the same example, employee ID, name, department, and location. If you replace this in a join as a left join, or we can specify left outer join as well, but the process or the method normally everyone uses just to mention left join, not a left outer join. Okay, now if you use this, what we will get is we will get all the records from the left table. Now which is the left table and which is the right table? Okay, that
Is
is
this
an
employee
question.
data?
So
This
whatever
employee.
table you are using in your from clause, okay, or your first table in the join conditions, that will be your left table. And the table used in the second or in the join condition, that is your right table. So our definition says left join will return all the rows from the left table. So it is saying like we will get all the rows from the left table, which is employee data table, and then matching rows with the right table. So wherever there is a match for the department ID, we will get that matching records as well. So let's execute this and you will see we are getting all the 14 rows from the employee table. And if there is no employees, we are getting the null values against that. Sorry, no department. So these two employees are not having the department information, right? Because if you see in the employee table, the employee ID 111 and 112, they are having the null as a department ID. So obviously, if we have the null department ID, where is, okay, we'll be getting null as a department name and location as well. Okay, so here as well, null and null is not matching. Okay, it is simply ignoring those record and the values against that will be tagged as a null, right? So we are getting all the records from the employee table, which is a left table. Okay, if I do the reversal here, what I'll do, I will use a department as a first table, which is first table in the sense it is a left table, and second table I am using employee data. Okay, now what will happen? I will get all
12,
the
right?
records from the department table. Okay, so I'm getting those like if you see, this is my first department, research and development. Okay, which is having a null value. Okay, so I'm getting that value as well. But against that department, what we are getting? We are getting null as an employee because this is a non-matching record. And there are three more departments we are having against which we don't have any of the employees assigned. Okay, so that records also we are getting here, right? So these are the three departments against which we don't have any of the employees, which means those are non-matching records. So still we are getting those records as well because
We're not
we are
getting department ID here.
we have not specified that in the select list.
Okay, but after the on keyword, we specified department ID column, right?
This is a join condition. Okay, you will get into the result set only the columns you mention into the select list,
Oh, okay. Got it.
right? So if you mention here employee name and I will just mention like department ID. So it will throw the error initially because department ID column is same in both of the table. So it will ask you to specify you want the department ID from which table.
So 1 minute.
Okay.
Sir, in a department table, we have only 8 rows. And an employee table, we have 14 rows.
Right.
And for the left join, as you said earlier, it retrieve all the left table data row, am I right?
Right.
With the matching or non-matching as well.
You're right.
But why we're getting a more than 8 row count here in a left join table?
Because each of these department, like let's say it is trying to return the first row into the department table, or let's say we talk about the second because first is a null. Dot departments. Okay, so I run both together. Remove this department ID column, or I will just keep that. I'll just give the name. Let's say I want this from the employee table. I'll run it together. Okay. So now our left table is a department table. So first it will try to retrieve this data. It will take this data into the result set. Okay. So now when it is trying to take the first row into the result set, it will see whether it is having the match. So as null will not match with the null. Okay. It is returning the first row, but the values against that employee record is null because it is not a matching record. Okay. Then it will go to the second record, human resource. Okay. So I'll just go down. So second record will be there in the result set, human resource. Okay, but for the human resource, there are two employees. Okay, and both are matching. So it is returning human resource twice. Information technology. Okay, the department ID 2. So there are three employees with the department ID, not three. There are five employees with the department ID 2, 101, 103, 1045, and 10. So it is returning that records. Okay, and for then finance, the third one. Okay, there are two employees with the three employees with the finance department, two employees with the marketing departments. Okay, there are no employees with the operations department, legal department, and research and development. So it is returning only once, and values against that for the employee ID and employee name will be null. Okay, so it is returning all the records from the left table. Now why it is showing 16 rows? Because there are matching rows we are having with this ID, and matching rows also need to be retrieved, right? When we are using left join.
Mm. Yeah.
Okay, so matching plus non-matching, both records will be coming out here. As we are using this into the select list, it is showing the multiple rows. If you are not using these columns from the employee table in your select list, it will show you only the 8 records. If you are not having these columns into a select list, okay, no, it should show all the records, even 16, because there are repeated value. We are using the join. Now if you use just a distinct, then it will show you only the value single time. Okay, so left join, what it will do, it will uh, return all the rows from the left table as well as the matching rows from the right table. And if you interchange the table, left and right table will be interchanged together. Okay, so whatever the table you are using into the form clause, that will be your first or the left table. The table you are using into the join condition, that will be your right table. Okay, now we will go with the three table example. Okay, now let's say this is the query we are having, right? And we are getting the information about the employees who are having the valid department ID and who are assigned to a valid project. Now let's say I don't want to see whether the employee is assigned to project or not. I want all the employee information. Okay, so I can use the left join here. Okay, so it will show you now, this query particularly will show you only those employee who are having the department ID. Department ID should not be null because we are using the inner join for the department and employee table, right? So this will be the giving only those employees who are having the valid department ID. But the second join, we are using left join. So now this will be your left table and this will be a right table. So we are getting all the employee information, whether it is having the department ID, whether it is having the project assigned or not. Okay, so with this now you will get 114 records, and there are records we are getting from the projects table. Okay, where there are no employees assigned, and for that we are getting project name as a null. So there are total 4 employees we are having, for which we don't have any project assigned. Okay, now let's say we are using the project name here, right? And we are getting the project name as a null here. I want to replace this null value. What I can use?
It's 0 as a null as project p dot.
No, instead of project name, if there is no project assigned, I want to mention like no project assigned as a name of the project. Currently, we are getting, for some of the employees, we are getting
We have
null
to
as
write
the
it
name
with a
of the
statement.
project. Null as a project name. I want to use some other name there. Did we see in the is null function?
Yes, sir.
Okay, so we can use is null here. So if this project name is getting null as a value, I want to replace that null with this value as project name. Okay, so what I did here, if I got the project name as a null, that will be replaced with no project assigned. Let's check whether it is working. Okay, so wherever there was null, we are getting this no project assigned as a value. Okay, same for the start date also we can do. If you are mentioning the start date, okay, but it is a date column, we cannot add the varchar value there, right?
We can use default date. Can we?
Default date something we can use, but no project, so we should not have the start date itself, right? So if it is null, maybe let's check whether blank will work there. It is defaulting to some date.
Yeah, 1911, 1911.
1900. Okay, so blank is defaulting to the default date to 900. Okay. Okay, so this is how we can replace. Okay, we can use all the conditions that we have learned till now. We can use functions, we can use group by, anything we can use in this uh, select list along with the join. So let's say you want to see the project name. Okay, p dot project name and the count of employees for each of the project. Okay, so I can use count function here, employee ID as employee count. Okay, so I can use the group by clause, group by the project name. Okay, we will get uh, the project name and total count of employees under each of the projects. So there are only one employee for each project, and there are 4 employees who are having the null as a project. That means no project name assigned. Okay, so where condition, join condition, you can use anything with the simple single select query or join condition as well. So whatever we have learned till now, we can apply everything out here. Okay, if you want like what do you say, department wise count of the employees, okay, with the name of the department and uh, the employees under it, count of employees. So you can use that as well. Select from dbo dot employee data e join dbo dot departments d on e dot department id is equal to d dot department id. Okay, group by d dot department name. So what I need is I want to find out the d dot department name, comma e dot employee id. Okay, and this I want count of this. I will just mention this as the employee count. So we'll get number of employees under each of the department. Okay, I
Yes.
want only those employees where the count is more than 2. I can use the having condition, having count of employees greater than 2. So I will get only those departments where the employees count is more than 2. Okay,
Yeah.
so there were the join like conditions we have seen where group by having all we can use here. E dot salary is greater than 60,000. I can use that condition as well. So it will filter first the records where the salary is more than 60,000, and then only it will uh, return the data.
So instead of is null, can you write for the case statement?
Right, we can write the case statement as well. Okay, I'll just show you. Okay, I will not much explain. We are going to see that in detail. So if you wanted to have this with the case statement, we can write the case statement as well. So case statement, how it works is we have to write case then we have to write a condition. When p dot project name is null, then what we need. So then will be the your value instead of that. Okay. This is one condition. If you have any other condition, you can write more conditions as well. If you don't have any other condition, just end this, give the name, project name, end as a project name. So it will also give you the same result. Okay, let's do one line to select. Okay. Now it is showing what is miss here, inner join and left join. So project name. P dot project.
And as a product. Why it's coming null then?
Oh, else we have to write because
And
this what we have written is we have written the case statement wherever there is a project ID, project name is null, then assign this value. But what if the project is not null? That we have not defined. So wherever there is a project is not null, it is showing the null values. So we have to specify else condition. So this is if the project is null, this value will be returned. What if this is not null? So if it is not null, return whatever it is, right? So whatever the value is there, it will return all the existing values. Okay, so this is how we write the case statement. Okay, ignore this, just I'm giving you the example. We will see this in detail. Okay, so this is the inner join and left join. Okay, simply we will just see one example in the reverse. Okay, if you want the record, now if you just simply use the right here, what will happen? It will return all the records from the department and matching records from the employee. So now right join is reverse of left. It will return all the records from the right table and matching records from the left table. Okay, so it will return all the departments and only the matching records from the employee tables. So right and left, it doesn't matter if you change the table from here to here. Okay, so normally in real time, we mostly use the left join. Okay, even though if you want to get the record, all the record from the second table, you will just interchange that table. So if I using left join here, so we are getting all records from the employee table here, right? With this example, this is a left join. Okay, what if I want all the records from the department table? So there are two things. Either you can change the left join to right join to get all the records from the department, or with the same left join, you can interchange the table, right?
Okay.
Does it make sense?
Yeah.
Both the things are the same. Okay, either you can replace the tables, interchange the table,
For
or you
left
can
join, it will
replace the
show from
join.
the left, and for the right join, it will show from the right, right?
Right,
Right table.
right.
Sir, one more
So
question.
yes.
So like here for like the on condition, you put like department ID for both, right? Both table.
Mhm.
Instead of that, can we put like any other column name like location or department or employee name if they are
You
matching
can,
together on different table? Is it
right.
possible?
If it is matching, you can put that. Okay.
Okay.
Like let's say in your employee table, you have the location stored. Okay, there is a column called the location, and you are having a column location in the department table as well.
Okay.
And you want to join based on the location, you can use that column as well.
Okay, but like the since we are using this condition like department ID, whatever condition we use in the result, it will not show, right? Those column. It's just for the condition, right? For
Right. It is
joining.
just a joining condition.
Okay.
Okay. If those columns are not there in the select list, it will not return into the result set.
Thank you.
Okay. Okay. So yeah, I think that's all for today. We'll see tomorrow. We'll continue with the join, the remaining types like right outer join. Yeah, though we have seen just as at high level today, we will again revisit the right outer join, then full outer join, and then we'll talk about the cross join and
Join.
self join on the later day. Okay,
Okay, so can you go back their query once again?
right. We can go back.
So here on employee data, the department ID, department, can we interchange these two?
We can interchange.
Yeah, that is the same thing, right?
Same thing. Either this is equal to this or this equal to this. Both are same thing.
Yeah. Okay,
Right?
okay. Got
The
it, got
writing
it.
one equal to one. So this one is from which table, no matter whether it is from A or
Order
B,
doesn't matter here.
right?
Okay.
Doesn't matter. So this is from A table, this is from B table, but both are same.
Okay, thank you.
Thank you.